to solve another Leetcode problem. 2510. Check if there is a path with equal number of 0 and 1's. So for this problem, it's really easy to understand. So we're going to start from the top left corner and until we go to the bottom right corner, and we want to find a path. So for example, this is a path. So in this path, we want to find the equal number of 0 and 1's. So for example, there are 3 zeros and 3 1's, so this is a valid path, so we're gonna return true. If we cannot find such a path, so we're gonna return a false. So definitely this is a great DP problem. So we're gonna use DFS plus memorization to solve the problem. So we're gonna start from the top left corner until we gonna go to the bottom right corner. And then we just check the number of 1's and the number of zeros. If they are equal, so we're gonna return true, otherwise we're gonna return a false. So let's just start coding for the problem. So I'm gonna prepare R and C. It's gonna be length of the grid and length of the grid 0. So I'm gonna use results. Gonna be the DFS. I'm gonna use DFS. I'm gonna start from the top left corner. It's gonna be 0 and 0. So I'm gonna prepare the number of 0 and the number of 1's. Yeah. And finally, I'm gonna return this result. But before I return it, I want to clear the cache. I'm not sure if there's any influence on it, but basically, if there are too many variables inside of the DFS, definitely it is better to clear the cache. So DFS dot cache clear. So we're gonna clear the cache. Now from here, we're gonna write the DFS, but before that, we're gonna use a cache. Let's just use a decorator of cache. So inside of the DFS, it's gonna be row and column and 0 and 1. So from here, from the beginning, we're gonna have a 0 and 0. So this means the number of 0 and the number of 1. And let me check if anything I need. Yeah, I think it's okay. So let's just check if this R more than equal to R or C more than equal to capital C. So we're gonna return a false. Definitely this is not possible because it goes out of the boundary. Now, if everything's okay, it means the row and column R and C is inside of the boundary, and we want to, basically we want to have a check. But before that, let's just update the 0 and 1's, because currently we want to check if grid RC equal to 1, so 1 gonna plus equal to 1, else 0 gonna plus equal to 1. Because I want to update the 0 and 1 first, because this 0 and 1 gonna be used for my later calculation. So from here, I can check if R equal to R minus 1 and C equal to C minus 1. Yeah, I just need to check. I just need to return a 1, return true if there's a valid path. So this means 1 gonna be equal to 0, otherwise it's gonna be a false. Yeah. So finally, as I already updated the number of 0 and the number of 1's, I can directly return the DFS for the two paths. It's gonna go to the right side and go to the bottom side. So it's gonna be R plus 1 with C and 0 and 1. Or R C plus 1 and 0 and 1. Yeah. So this is going to be the final solution for the problem. So from the beginning, we're going to prepare this R and C and going to prepare DFS. Here we're going to clear the cache. So now let me just run it. Yeah, let me check what is the wrong invalid syntax. Yeah, why it is an invalid syntax? Let me just I think I'll forget about the if return true if 1 equal to 0, else it's gonna be a false. So the function 2, this object should has no attribute class. Yeah, so it is not called class dot clear. It is a class dash clear. Yeah. Now let me just run it. Now as you can see it works, and let me submit it. Yeah, as you can see it works. So maybe we don't want to clear the cache. Let's just have a check. So if we didn't want to clear the cache, as you can see here is the memory and here is the speed, and let's just run it. I think the memory gonna increase. As you can see, the memory increased and the speed is nearly the same. So it is always dependent on us whether we want to clear the cache or not. Yeah, but I think by using the DFS is gonna be an easy way to solve the problem. As you can see, we didn't have too much control of the DFS, and it's easier to code. I think that's all about it. And if we were to analyze the time complexity, it's gonna be, it's gonna be 100 times 100, 100 to the power of 4. Basically, it is a mn square, m times n square. Yes, so this is a square, m times n square. It's going to be the time complexity. Thank you for watching. See you next time.